Welcome to Ask and Learn.
So in this problem, we have a collar that weighs 10 pounds and is being moved up the rod by a constant force of 25 pounds. And we want to know the power that this generates as soon as the angle is 60 degrees. So we can also convert the weight to mass by dividing by 32.2 feet per second squared. So for the mass of the collar, we have 0.31 kilograms. Since we're dealing with power, we know that a variation of the equation of power is the force times the velocity. But in this problem, we have the force at some angle and the velocity is going up, straight up the rod. And the angle it creates is 60 degrees. So power becomes force times velocity times cosine of that angle, theta. So we know the force and we know the angle, so what's missing is the velocity. So to find the velocity, we can use the work energy theorem to find the velocity. Since we're dealing with movement, that means that there's a kinetic energy involved. And because the movement is due to a force, that means there's work going on as well. So that's why we can use the work energy theorem, which is the initial kinetic energy plus the work done by the forces is equal to the final kinetic energy. But in this problem, the collar starts at rest, so the initial kinetic energy is 0 because at that instant the velocity is 0. So then this becomes, so just leave work alone for a second. So work is equal to, and then final kinetic energy is 1/2 m v2 squared. And this is the velocity we're trying to solve. We can call this equation 1. So again, from this problem, we know the mass, but we don't know the work involved. So now let's find the work. And we know that work is force times distance. And the forces involved here is the force of 25 pounds and also the weight of the collar. So we have the force 25 pounds times the distance it travels. But that's what we don't know as well. So if we think about it, initially we have a triangle, right? We have the height 4 and we have the distance x, the x in the x direction 3. So we can find the hypotenuse, 4 squared plus 3 squared square root, and we get 5. So this is the position initially, but then it moves until it reaches 60 degrees, an angle of 60 degrees. So we don't know the vertical, it's called that y2. The x direction still remains the same, 3, and the hypotenuse changes as well. We can call that L2. And of course the angle here is 60 degrees. So then the distance, the force would be L1 minus L2 minus, and then the weight is in the opposite direction of this 25-pound force, so the work will be negative. So we have the weight and its distance will be in the vertical, so we have y1 minus y2, and of course that times w. So now let's find y2 and L2. So from that triangle we can say sine theta is equal to 3 over L2. So then just solve for L2. and we get 3 divided by sine of 60. So for L2, we get 3.5 feet. And now let's look for Y2. So for Y2, we can say tangent theta is equal to 3 divided by this Y2 to solve for Y2. And we get 3 divided by tangent 60. So Y2 is 1.7 feet. So now we can plug in these numbers to find work. So we have work is equal to F, the force that's given, 25 times 5 minus 3.5 minus the weight, 10 times 4 minus 1.7. So for work, we get 15.7 pounds per feet. Now we can plug this back in to our work energy equation. So we have the work, 15.7 is equal to 1/2 and then m.31 times v2 squared. So if we solve for v2, we get 31.4. So we get this by multiplying both sides by 2 divided by 0.31. And then to get rid of the square, take the square root of both sides. So v2, the velocity of the collar, is 10.06 feet per second. And now finally, since we have velocity, we can plug this in back into our equation 1. So power is equal to the work, the force, 25, times the velocity we just found, 10.06, times cosine of the angle between them, which is cosine of 60. And so we get 125.75 pounds feet per second. We can convert this to horsepower, multiplying by 1/550 pounds per feet seconds. So the power in horsepower is 0.23.